Hello, today we are going to be looking at adding and subtracting fractions. As we know, a fraction is not a whole number. A fraction describes how many parts of the whole number there is. So with that, you might have 1/2 or 1/4. With that, a fraction can be simplified into a decimal by solving or simplifying the fraction. So 1/2, if we actually computed that, would be 0.5, and 1/4, if we actually computed that, would be 0.25. As a decimal, if you take 0.5 and add 0.25, we would get 0.75. However, if you keep it in a fraction and you have 1/2 plus 1/4, how do you get 0.75? And that's what we'll be looking at today. With adding and subtracting fractions, all you need to do is ensure that the denominator, which is the number in the bottom of both fractions, are the same. And then once the denominator in both fractions are the same, all you need to do is add the numerator of one fraction with the numerator of the remaining fraction, and you'll get your answer. If we look at this example that we have right here of 1/2 plus 1/4, what number times 2 will give us a multiple of 4? Now, before we go into this problem, I want to go over a couple rules. The rule that I want to explain is that if you multiply a number by 1, you're going to get that number. Similarly, if you divide a number by itself, you'll also get 1. So what do I mean by that? Well, if we take 2 divided by 2, we're going to equal 1. Now, if I multiply 1 times 2 over 2, that's really equal to 1 times 1, which is equal to 1. So we didn't change anything. I could do 1 times 4 over 4. That's still going to be equal to 1 times it by 1, which is still equal to 1. So with these rules, a number divided by itself and a number multiplied by 1, giving us the same value that we started with, we are going to apply that to fractions. If we go back to our example of 1 divided by 2 plus 1 divided by 4, we ask ourselves, how can I make the denominators the same? In this case, we see that if we multiply this value here by 2, then that's going to give us 4. With the rule that we just discussed, if we want to multiply a number, so we have 1/2, and we multiply the bottom by 2, we also need to multiply the top by 2, because really 2 over 2 is equal to 1, and 1 times 1/2 is equal to 1/2. So we're not changing the value. However, if we do 2 multiplied by 2 to get us 4 on the bottom, we also need to do 2 multiplied by 1 to give us 2 on top. So now we can rewrite the problem as 2 divided by 4 plus 1 over 4. Now that we have the same denominator here and here, all we need to do is add the numerator together. If we add the numerator together, we're going to get 2 plus 1 is equal to 3 over 4. And this is our answer, 3/4. Now, if we decide to simplify this and turn it into a decimal, this is equal to 0.75, which is exactly what we got when we added the decimals together. So that is how you add and subtract fractions. You need to get the denominator to the same value. After you've gotten the denominator to the same value, you add the numerators together, and that is your final answer. Let's look at a few more examples. Looking at our next example, we have 3/7 plus 9/11. Again, what we need to do first is we need to get the denominators to be the same. So the number here needs to match the number here. After we have completed getting the denominators the exact same, all we'll need to do is just add the numerator together and we will have our answer. So we ask ourselves, how do we get 7 and 11 to the exact same? Well, if you don't know a number that has the factors of what's located in the denominator, a really good rule of thumb or something easy you can do is just multiply each denominator by the opposite denominator. And so if we do that, then we would do 3 divided by 7, and we use the 11, so we multiply this one by 11 over 11, and then we have plus 9 divided by 11, and we multiply this by 7 over 7. If we multiply the 7 by the 11, and we multiply the 11 by the 7, then we're going to get the exact same answer because it's the exact same multiplication problem. The difference will be when you multiply the numerators together. Now that we have this, all we need to do is solve. So 11 times 3 is 33, and 11 times 7 is 77. Our next fraction gives us 9 times 7, which is 63, and then we get 11 times 7, which is 77. Now, all we need to do is add the numerator together. If we add the numerator together, we're going to get 96 over 77. At 96 over 77, this can be reduced down. There is 177 within 96, and what's left is 19. Therefore, our answer is 119 over 77. Similarly, if we wanted to use this exact same problem and do a subtraction, then it would be the exact same rule and the exact same method. We will multiply each side by 1 to get the denominators to be the same, and this would be 33 over 77, in this case minus 63 over 77. When we do this, we're going to get negative 30 over 77, and this is our answer. Doing addition and subtraction, the only difference would be that sign in the middle. However, your process to solve them would be identical. Let's look at one more example. All right, looking at our last problem, if you'd like to pause the video and see if you can do this one for yourself, I would suggest that you do that. After you've completed it, press play and see if we got the same answer. There are two main ways that you can do this problem. You could leave these whole numbers out in front and then only work with the fractions, or you can turn the entire problem into a fraction, work with both units as a fraction, and then simplify it later. Both ways are valid, and it's a personal preference. I will show you both methods just in case you prefer one over the other. Keeping the whole numbers intact, we have 2 plus 5, which gives us 7, and then that leaves us with 3 over 4 plus 1 over 3. So then it really becomes a problem between 3/4 plus 1/3, and then when we get that answer, we'll add it to the 7. If we focus on 3 over 4 plus 1 over 3, the first question we need to ask ourselves is how can we get 4 and 3 to be the exact same denominator? Again, an easy way to do it is just take the 4 and multiply it to the 3. Similarly, you would take the 3 and multiply it to the 4. So if we did that, we're going to get 3 over 3 multiplied by 3 over 4, because the 3 over 3 is equal to 1, so we're not changing the value, plus we have 1 over 3, and we need to take it by 4 now to get 4 divided by 4. Again, multiplying by 1, not changing the value, and then we still have the 7 left over from the whole number. 3 times 3 equals 9 over 12, plus 4 times 1 is 4, divided by 3 times 4 is 12. And we still have our 7 as our whole number. We can now add the fractions together because the denominators are the same. And to do that, all we need to do is add the numerators. So this then becomes 9 plus 4, which gives us 13 over 12 plus 7. Okay? 13 over 12 simplifies down to 1 over 12 plus 7. If we take 13 divided by 12, it's going to give us 1, and there's going to be 1 left over. And so that's how we get the 1 and 1 over 12, and we still have 7. Now all we have to do is add the whole numbers together, and this gives us 8 and 1/12. And this is our final answer. It can no further be simplified, and we have completed all the steps. Looking at a second way to do it, rather than working with the whole number out in front like we did with the 2 plus 5, you can change these fractions into improper fractions. If we have 2 3 over 4, all you need to do is take 2 times 4, you take 2 times 4, and then you add 3, and then you divide it by the denominator. So the numerator would become 2 times 4, which is 8, plus 3, which is 11, and it would still be over 4. Because if we simplified this, this would be 4 can go into 11 2 times, and 2 times 4 is 8. That means there's 3 left over. So that's how we did it. All we did, multiplied your denominator by your whole number. So 4 times 2, add 3, that becomes the numerator, which is 11, and then we keep the denominator the same, which is 4. So we will use this value as the improper fraction. Similarly, we would need to do that with the second term. We take 5 and 1/3, and this becomes 3 times 5 plus 1 over 3. If we do 3 times 5, that gives us 15, plus 1 is 16, 16, and the denominator stays the same at 3. Again, if we wanted to check our work, 16 divided by 3, 3 can go into 16 5 times, and there's still 3. 5 times 3 is 15. 15 means there's 1 left over, 5 and 1/3. So now we have our second term. All we need to do is now take 11 divided by 4 plus 16 divided by 3. We have to get the denominators, this number and this number, to be the same, and then we add the numerators together after we get the denominators to be the same. We multiply each term by the other term's denominator. So 11 over 4 would get multiplied by 3 over 3. So we get 3 over 3 multiplied by 11 over 4 plus, and again, 3 divided by 3 is 1, so we're not changing anything, 16 divided by 3 multiplied by 4 over 4. 11 times 3 is 33, divided by 3 times 4 is 12, and then we do 16 times 4, which is 64, and we do 3 times 4, which is 12. Now we add the numerators together because the denominators are the same. If we add the numerator, we're going to get 97 divided by 12. And once this is simplified, this becomes 12 can go into 97 8 times, and then 8 times 12 gives us 96, which means there's 1 left over, and this is our answer. And this is the exact same answer that we got when we did it the other way as well. If If you have any questions, please leave them in the comments below. If you learned something, please like and subscribe, and we'll see you next time.